Hey there, how was your day? Wherever you are in the world, whatever time it is, I'm glad you're here. Tonight, we're going to embark on a journey so vast, so impossibly distant, that it challenges everything we think we know about the future of existence itself. What would you see if you could travel 1 billion years into the future? What would remain of our planet, our solar system, our very reality? In this gentle exploration, we'll drift through deep time itself, witnessing transformations so profound they reshape the very meaning of permanence. The visuals are here for you, but feel free to close your eyes, breathe deep, and let your imagination carry you across eons of cosmic time. I would love and encourage you to watch this journey to its end to discover the breathtaking vistas that await. But there is absolutely no problem if you doze off along the way. Let your thoughts float across the centuries like whispers in the cosmic wind. A gentle request that if you find comfort in these explorations of deep time, I'd be grateful if you'd consider subscribing and liking this video. It helps others find these quiet contemplations of our cosmic future. Also, I'd love to know where you're listening from tonight. Feel free to comment your time and location below. There's something beautifully humbling about contemplating the far future while scattered across our small planet, each of us experiencing this moment under the same sky that will witness transformations beyond our wildest imagination. Let's begin this journey into the deep future, where time itself becomes our vessel and wonder our compass. You're standing in your backyard on a quiet evening, feeling the familiar weight of gravity beneath your feet, breathing air that has sustained life for billions of years. Now imagine that same spot, that exact location where you stand, but 1 billion years from now. What would you find there? What would remain of everything you know? This isn't science fiction. This is science itself, peering forward through the mathematics of stellar evolution, geological processes, and cosmic mechanics to paint a portrait of Earth's far future that is both beautiful and haunting. Because here's what most people don't realize about deep time. 1 billion years isn't just a long time. It's a span so vast that it dwarfs the entire history of complex life on Earth. Think about this. 1 billion years ago, the most sophisticated life forms on our planet were simple bacteria and algae. There were no animals, no plants, no forests, no eyes to see or minds to wonder. The oxygen in our atmosphere was still building up from ancient cyanobacteria. Complex cells had only recently learned to work together. Everything we associate with life on Earth, from the first fish to the dinosaurs to human civilization, has unfolded in less than 1 billion years. Now we're asking what happens in the next billion. We're peering forward across a chasm of time that spans the entire evolutionary journey from microbes to consciousness. And what we discover is that this journey into the deep future reveals something profound about the nature of change itself. The first thing you would notice in our billion-year future is the sky. The sun, that steady companion that has warmed our world for over 4 billion years, has been slowly growing brighter throughout its life. This isn't a sudden change, but a gradual transformation written into the very physics of stellar evolution. As hydrogen fuses into helium in the sun's core, the star becomes more luminous, more energetic, more intense. In 1 billion years, the sun will be roughly 10% brighter than it is today. 10% might not sound dramatic, but in the delicate balance of planetary climate, this increase is catastrophic. The additional energy will trigger a runaway greenhouse effect that will fundamentally transform our world. The oceans, those vast blue expanses that have defined Earth for billions of years, will begin to boil away into space. Imagine standing on that future Earth and looking up at a sky devoid of the familiar blue we've known throughout human history. Instead, you would see a harsh, brilliant dome of superheated steam and vapor. The water cycle that has shaped weather, carved landscapes, and sustained life will have broken down completely. Rivers will have long since evaporated. Lakes will exist only as salt flats and dried basins. The polar ice caps will be nothing but memory. But the story of water's departure is more complex and beautiful than simple boiling. As temperatures rise and the atmosphere fills with water vapor, something remarkable happens. Water vapor rises high into the atmosphere, where ultraviolet radiation from the sun breaks it apart into hydrogen and oxygen. The lightweight hydrogen escapes to space, lost forever, while the oxygen remains behind. Earth's atmosphere will become incredibly oxygen-rich, creating conditions unlike anything in our planet's history. This oxygen-rich atmosphere will have profound effects on any remaining geology. Rocks will oxidize at accelerated rates. The familiar colors of landscapes will shift toward rusty reds and brilliant oranges as iron compounds react with the abundant oxygen. The very ground beneath your feet will tell the story of water's departure through its transformed chemistry. Yet even as the familiar Earth disappears, new forms of beauty emerge. Without water to moderate temperatures and create weather patterns, the planet's surface will become a realm of extremes. Of degrees, while nightside regions' eyeside temperatures may soar to hundreds, could remain relatively cooler, creating temperature gradients that drive winds of incredible power across the barren landscape. The moon, our ancient companion, will still hang in the sky, but it too will have changed. Over the course of 1 billion years, the gradual recession of the moon will have continued. Each year, the moon moves about 3.8 centimeters farther from Earth, as tidal interactions slowly transfer rotational energy. After 1 billion years of this process, the moon will appear noticeably smaller in the sky, and its gravitational influence will be weaker. This changing relationship between Earth and moon will have affected the planet's rotation. Earth's day will have grown longer, perhaps lasting 30 or 40 hours instead of our familiar 24. The slower rotation will create different patterns of atmospheric circulation, different rhythms of heating and cooling, different ways that energy moves around the planet. But what about life? Could anything survive this transformation? The answer reveals something remarkable about the tenacity of biology. While complex surface life will have long since vanished, certain forms of life might persist in unexpected places. Deep underground, in caves and rock formations far from the surface heat, communities of bacteria and archaea might continue to thrive. These extremophiles, organisms that live in conditions we would consider impossible, represent life's last stand on a transforming world. These underground ecosystems will have evolved in isolation for hundreds of millions of years, possibly developing into forms we can barely imagine. Without sunlight, they will depend entirely on chemical energy from rock interactions, radioactive decay, and geothermal processes. They might represent an entirely new branch of life's tree, as different from current organisms as current organisms are from the earliest bacteria. The geological story of this future Earth is equally fascinating. Without water to drive erosion and weathering, the processes that shape landscapes will operate differently. Wind erosion will continue, but without the moderating effects of vegetation and water, it will carve the land in new ways. Ancient mountain ranges will be slowly ground down, while new formations created by thermal expansion and contraction emerge. Volcanic activity will continue, possibly intensified by the changing thermal conditions. These volcanoes will release gases and minerals into the atmosphere, contributing to the planet's evolving chemistry. The dance between geology and atmosphere that has operated throughout Earth's history will continue, but according to new rules written by the absence of water, the polar regions, once defined by ice and snow, will become landscapes of exposed rock and ancient sediments. The geological record of Earth's watery past will be laid bare, creating a kind of museum of planetary history written in stone. Future visitors, if any exist, could read the story of oceans and rivers in the stratified rocks, like pages in a book describing a world that once was. Yet even as we contemplate this transformed Earth, we must remember that 1 billion years is time enough for surprises. The history of our planet is filled with unexpected events that have reshaped everything. Asteroid impacts, supervolcanic eruptions, changes in solar output, and even the effects of nearby stellar events could alter this trajectory in ways we cannot predict. There's something both humbling and beautiful about contemplating these vast timescales. They remind us that change is the only constant, that even the most permanent seeming features of our world are temporary arrangements in the long dance of cosmic evolution. The mountains we consider eternal will be worn away. The oceans we think of as everlasting will boil into space. Yet new forms of order and beauty will emerge from these transformations. As we continue our journey through this billion-year future, we'll explore what happens beyond Earth, to our solar system, to the stars themselves. We'll discover how the story of our transformed planet fits into the larger narrative of cosmic evolution, and we'll contemplate what it means for consciousness, for meaning, for the possibility of life itself in a universe that never stops changing. But for now, as you rest here contemplating these vast transformations, remember that you are part of this story. Every breath you take connects you to the atmosphere that will one day escape to space. Every step you take touches ground that will one day be transformed beyond recognition. You exist in a brief, beautiful moment in the long history of change, a conscious observer in the ongoing dance of matter and energy that we call existence. The billion-year future awaits, vast and strange and wonderful, and we have only just begun to explore its mysteries. Beyond our transformed Earth, the solar system itself will have undergone changes that would render it nearly unrecognizable to our eyes. The dance of planets that has maintained its rhythm for billions of years will continue, but with subtle variations that accumulate into profound differences over such vast timescales. Mars, that rust-colored neighbor we've dreamed of visiting, will have evolved in its own quiet way. Without the moderating influence of a thick atmosphere or abundant water, Mars changes slowly, but change it does. The planet's thin atmosphere will have continued its gradual escape to space, molecule by molecule, year by year. After 1 billion years of this patient exodus, Mars will be even more airless than it is today, its surface pressure dropping to levels that make our current Martian atmosphere seem thick by comparison. The polar ice caps of Mars, those seasonal deposits of frozen carbon dioxide and water, will have undergone countless cycles of growth and retreat. But the overall trend will be toward diminishment as the planet's already tenuous grip on its atmosphere weakens further. The great dust storms that occasionally engulf the entire planet will become rarer, not because the winds have calmed, but because there's simply less atmosphere to carry the dust. Yet Mars holds secrets that 1 billion years will slowly reveal. Deep beneath its surface, in caverns and rock formations we've never imagined, processes will continue that might surprise us. The planet's core, still warm from its formation and the decay of radioactive elements, will continue to drive subtle geological activity. Occasional volcanic eruptions might still punctuate the Martian silence, releasing gases that briefly thicken the atmosphere before they too escape to space. Jupiter, that massive guardian of the outer solar system, will maintain its stately presence. But even this giant will show signs of deep time's passage. The Great Red Spot, that storm larger than Earth itself, may finally dissipate after raging for centuries or millennia beyond our current era. New storms will form and fade, each lasting for spans of time that dwarf human civilization, yet appearing as mere moments in Jupiter's billion-year story. The moons of Jupiter will continue their intricate orbital dance, but tidal forces will have subtly reshaped their paths. Europa's icy surface will have been renewed countless times as its subsurface ocean continues to interact with the rocky core below. If life exists in those dark waters, it will have had 1 billion years to evolve in isolation, potentially developing into forms as different from Earth life as we can imagine. Jupiter's volcanic moon will have exhausted more of its internal heat, though sulfur volcanoes may still paint its surface in brilliant yellows and oranges. The constant gravitational kneading from Jupiter will continue, but perhaps less vigorously, as the system slowly loses energy to gravitational waves and tidal friction. Saturn's rings, those magnificent bands of ice and rock that have captivated human imagination, present one of the most poignant stories of our billion-year future. These rings are not permanent fixtures, but temporary decorations in cosmic terms. Current estimates suggest they formed relatively recently, perhaps only a few 100 million years ago, and they won't last forever. Over the course of 1 billion years, Saturn's rings will gradually spiral inward, consumed by the planet's gravity and magnetic field. The process is slow but inexorable. Ring particles collide and lose energy, causing them to drift towards Saturn. Some will be absorbed by the planet's atmosphere, while others will be swept up by the many small moons that orbit within the ring system. Future observers looking at Saturn in our billion-year destination might see only faint remnants of the spectacular ring system we know today. Perhaps a few tenuous bands will remain, or maybe the rings will have vanished entirely, leaving Saturn as just another gas giant without its distinctive crown. The thought carries a strange melancholy, like imagining a future where no one remembers the sound of rain. But Saturn may compensate for this loss with new wonders. Its moon Titan, with its thick atmosphere and lakes of liquid methane, will continue evolving its own unique chemistry. The interplay between Titan's atmosphere, surface, and subsurface ocean creates a complex system that could surprise us with new developments over such vast timescales. Uranus and Neptune, those distant ice giants, will maintain their lonely vigil at the edge of our solar system. Their positions will have shifted slightly due to gravitational interactions with other planets and passing stars. But these changes will be subtle. What's more interesting is how their internal heat sources will have evolved. Both planets radiate more heat than they receive from the Sun, and this internal warmth will continue to drive weather patterns and atmospheric dynamics across our billion-year time span. The Kuiper Belt, that vast collection of icy bodies beyond Neptune, will have been sculpted by countless gravitational encounters. Some objects will have been scattered inward toward the Sun, creating spectacular comets that briefly illuminate the inner solar system before fading. Others will have been flung outward into the even more distant Oort cloud, or lost to interstellar space entirely. Perhaps most remarkably, our solar system will have encountered other stars during its billion-year journey around the galaxy. The Sun, along with all its planets, orbits the center of the Milky Way once every 225 million years. In 1 billion years, we will have completed more than 4 full galactic orbits, passing through different regions of space, encountering different stellar neighborhoods. During these travels, other stars will have approached our solar system, some coming close enough to perturb the orbits of comets in the Oort cloud, or even affect the outer planets' trajectories. These stellar encounters, while rare, could dramatically reshape the architecture of our solar system. A close pass by another star might scatter comets throughout the inner system, creating a prolonged period of bombardment. Alternatively, it might strip away some of our system's most distant objects, stealing them into interstellar space. The Sun itself will tell the most dramatic story of transformation over this time span. As we've seen with Earth's changing climate, the Sun's gradual brightening will affect all the planets. Mars might briefly experience a renaissance, as increased solar heating could theoretically release gases from its polar caps and subsurface reservoirs, creating a temporary thickening of its atmosphere. Venus, already hellishly hot, will become even more extreme as the enhanced solar output drives its greenhouse effect to new heights. But beyond these planetary effects, the Sun's evolution will manifest in ways both subtle and profound. Solar flares and coronal mass ejections will continue to erupt from its surface, but their character may change as the Sun's magnetic field evolves. The solar wind, that constant stream of charged particles flowing outward from our star, will intensify, gradually stripping away more of the planetary atmospheres and affecting the magnetic fields of worlds throughout the system. The asteroid belt between Mars and Jupiter will continue its slow evolution, with collisions gradually grinding large asteroids into smaller fragments. Some of these fragments will eventually spiral inward toward the Sun, while others will be captured by planetary gravities or flung outward. The belt will become more diffuse over time, though it will never disappear entirely. Throughout all these changes, the fundamental physics that governs our solar system will remain constant. Gravity will continue to orchestrate the dance of worlds. Electromagnetic forces will shape planetary magnetospheres, and thermodynamics will drive the flow of energy from hot to cold. Yet within these unchanging laws, endless variations will play out, creating new configurations, new relationships, new possibilities for beauty and complexity. As we contemplate this transformed solar system of our billion-year future, we begin to appreciate the true nature of cosmic time. What seems permanent to us, the arrangement of planets and moons we see in our night sky, is actually just a momentary configuration in an endless dance of gravitational interactions. The solar system is not a static mechanism, but a living, evolving entity that will surprise us with new developments, even across the vast spans of deep time. And yet, for all these changes, something will remain recognizably familiar. The Sun will still shine, though more brightly. Planets will still orbit, though along slightly different paths. The basic architecture of our cosmic neighborhood will persist, even as its details transform beyond recognition. This persistence within change, this continuity within transformation, hints at something profound about the nature of existence itself. Even as we prepare to explore what lies beyond our solar system in this billion-year future, we carry with us the understanding that change and permanence are not opposites, but partners in the cosmic dance that connects every moment to eternity. As we venture beyond our transformed solar system, we encounter changes so vast, they challenge our understanding of permanence itself. The stars, those eternal beacons that have guided human navigation and imagination since our species first looked upward, will have undergone their own profound transformations across this billion-year span. The constellation patterns that have remained relatively stable throughout human history will have shifted noticeably. Stars move through space at different velocities, and over 1 billion years, these proper motions accumulate into visible changes. The Big Dipper will no longer resemble a ladle, Orion's belt will have scattered. The Southern Cross will have drifted into new configurations. Future observers, if they exist, will see an entirely different tapestry of stellar patterns painted across their night sky. But the changes run far deeper than mere stellar rearrangement. Many of the stars visible in our current night sky will have completed their life cycles entirely. Massive blue giants, those spectacular but short-lived stellar torches, will have long since exhausted their nuclear fuel and died in supernova explosions of unimaginable violence. These cosmic detonations will have scattered heavy elements throughout space, seeding future generations of stars and planets with the materials necessary for complexity. Some of these stellar deaths will have occurred relatively nearby, close enough to affect our solar system directly. A supernova within 50 light years could strip away portions of our outer planet's atmospheres or trigger climate changes even on our already transformed Earth. The radiation from such explosions might briefly illuminate our solar system with ghostly auroras, painting the sky in colors we've never seen. Other stars will have evolved more gradually. Sun-like stars in our neighborhood will have swollen into red giants before shedding their outer layers and collapsing into white dwarfs. These stellar remnants, incredibly dense cores, no larger than Earth, but containing the mass of an entire star, will dot the galaxy like cosmic lighthouses, slowly cooling over timescales that dwarf even our billion-year journey. The galaxy itself will have rotated, carrying our solar system through different regions of space. We will have passed through spiral arms, those regions of enhanced star formation, where massive young stars illuminate vast clouds of gas and dust. During these passages, the night sky will have blazed with nebulae of extraordinary beauty, stellar nurseries where new suns are born from the gravitational collapse of interstellar material. Between these spiral arms, our solar system will have traversed quieter regions of space, cosmic suburbs where stars are more widely separated and the interstellar medium is thinner. These periods will offer different perspectives on the galaxy, different views of distant star clusters and nebulae, different exposures to cosmic radiation and interstellar particles. Throughout this galactic journey, our solar system will have encountered the invisible presence of dark matter, that mysterious substance that outweighs ordinary matter by 5 to 1. While dark matter rarely interacts with normal matter except through gravity, over billion-year timescales, even these weak interactions could subtly influence planetary orbits and the behavior of comets in our system's outer reaches. The Milky Way itself will be preparing for its own grand transformation during this epoch. Our galaxy is currently on a collision course with the Andromeda Galaxy, and while this cosmic merger won't begin in earnest for another 4 billion years, the gravitational effects will become increasingly noticeable during our billion-year time frame. Tidal forces between the two galaxies will begin to distort their spiral structures, creating streams of stars and gas that stretch across hundreds of thousands of light years. This approaching merger will affect star formation rates throughout both galaxies. Gravitational interactions will compress gas clouds, triggering bursts of stellar birth that will illuminate the cosmic landscape with brilliant young stars. Simultaneously, some existing star systems will be scattered into the intergalactic void, becoming cosmic nomads traveling through empty space between galaxies. But perhaps the most profound changes will be occurring on scales we can barely perceive. The fabric of space-time itself will be rippling with gravitational waves, those distortions in the geometry of reality created by accelerating masses. Over 1 billion years, these waves will carry away energy from orbiting systems throughout the galaxy, causing binary stars to spiral inward and eventually merge in spectacular displays of gravitational radiation. Some of these mergers will involve neutron stars, those incredibly dense stellar remnants where a teaspoon of matter would weigh as much as a mountain. When neutron stars collide, they create kilonova explosions that forge heavy elements like gold and platinum, scattering these precious materials throughout space. The universe will have experienced thousands of such events during our billion-year span, gradually enriching the interstellar medium with the building blocks of complexity. Black holes, those regions where gravity has become so strong that not even light can escape, will continue their patient consumption of surrounding matter. Some will have grown substantially, feeding on gas and dust and occasional stellar companions. Others will remain quiescent, invisible except for their gravitational influence on nearby objects. The supermassive black hole at the center of our galaxy will continue orchestrating the dance of stars in the galactic core, its 4 million solar masses mass presence shaping the evolution of our cosmic neighborhood. Yet even as we contemplate these vast scales and cosmic transformations, we must remember that 1 billion years allows time for the unexpected. Gamma-ray bursts from distant galaxies might bathe our region of space in high-energy radiation. Nearby star formation might create massive stellar associations that alter the local environment. Rogue planets ejected from other star systems might pass through our cosmic neighborhood, briefly disturbing the gravitational balance we've known for so long. The interstellar medium itself, that thin soup of gas and dust between the stars, will have been stirred and mixed by stellar winds, supernova explosions, and the passage of our solar system through different galactic regions. New chemical combinations will have formed in the cold darkness of space, creating complex organic molecules that drift through the void like seeds waiting for the right conditions to flourish. Perhaps most remarkably, this billion-year span will have allowed time for entirely new forms of stellar evolution to manifest. Stars that are just beginning their main sequence lives today will have burned through significant portions of their hydrogen fuel. Binary star systems will have exchanged mass, creating exotic configurations we can barely imagine. White dwarf stars will have accreted material from companions, possibly triggering nova explosions that briefly outshine entire galaxies. The cosmic web itself, that vast network of dark matter filaments that connects galaxy clusters across the universe, will have evolved subtly but significantly. Structure formation will have continued on the largest scales, with galaxy clusters merging and growing, while voids between them expand and empty. Our local group of galaxies will have shifted position within this cosmic architecture, changing our perspective on the distant universe. Throughout all these transformations, the fundamental constants of physics will have remained steady. The speed of light will still define the maximum rate of information transfer. Gravity will continue to attract mass and energy according to Einstein's equations. Quantum mechanics will still govern the behavior of particles on the smallest scales. Yet within these unchanging laws, endless creativity will have manifested, producing new arrangements of matter and energy that we cannot yet imagine. This is the context within which our transformed Earth and solar system exist in the billion-year future. We are part of a vast, interconnected cosmic ecosystem, where changes on one scale influence developments on all others. The death of a massive star enriches the interstellar medium that will someday form new planets. The merger of galaxies creates conditions for enhanced star formation. The slow evolution of the universe itself provides the stage upon which all these dramas play out. As we continue our journey through this deep future, we begin to understand that transformation is not something that happens to the universe, it is what the universe is. Every moment brings new configurations, new possibilities, new expressions of the creative potential inherent in the fundamental laws of nature. The billion-year future is not a destination, but a continuing journey, an ongoing exploration of what is possible when matter and energy dance together across the vast expanses of space and time. And somewhere in this transformed cosmos, in this galaxy reshaped by eons of change, our little solar system continues its ancient orbit, carrying with it the story of a small blue planet where consciousness once arose and dared to wonder about its place in the grand symphony of existence. Looking deeper into this billion-year canvas, we discover that the very atoms that compose everything around us will have embarked on journeys of their own. The carbon in your body, forged billions of years ago in stellar cores, will have cycled through countless forms during this vast span. Some atoms will have been locked in crystalline structures deep underground. Others will have drifted through space as cosmic dust, riding stellar winds between star systems. Still others will have been incorporated into new worlds, new atmospheres, new possibilities for complexity. The recycling of matter operates on timescales that humble our understanding of permanence. Every handful of Earth contains atoms that have witnessed the birth and death of stars, the formation and erosion of mountains, the rise and fall of countless atmospheric compositions. In our billion-year future, this cosmic recycling will have accelerated and intensified as stellar evolution reaches new phases throughout our galactic neighborhood. Consider the hydrogen in water molecules that once filled Earth's oceans. As these molecules escape to space and are broken apart by solar radiation, the hydrogen atoms begin individual odysseys that could carry them across the galaxy. Some will be swept up by the solar wind and ejected from our system entirely. Others might be captured by the magnetic fields of gas giant planets, becoming part of their extended atmospheres for millions of years before being released again. This atomic diaspora reveals something profound about the nature of identity and continuity. What we consider to be permanent substances are actually temporary arrangements of wandering particles. The iron in your blood has traveled an unimaginable distance through space and time, and it will continue that journey long after your brief biological moment has passed. But matter doesn't travel alone through this deep future. Energy accompanies it in forms both familiar and exotic. The heat generated by radioactive decay in Earth's core will continue warming our planet's interior for billions of years, though at gradually diminishing rates. This thermal energy will still drive geological processes, creating convection currents in the mantle that push and pull on the transformed surface above. Magnetic fields will continue to play crucial roles in shaping the environment of our future solar system. Earth's magnetic field, generated by the motion of molten iron in its outer core, will have evolved significantly over our billion-year span. The field's strength may have varied dramatically, perhaps reversing polarity hundreds of times, each reversal lasting thousands of years and temporarily exposing the surface to increased cosmic radiation. These magnetic fluctuations will have sculpted the upper atmosphere in ways we can barely imagine. During periods of weak magnetic protection, energetic particles from space will penetrate deeper into the atmospheric layers, creating chemical reactions that alter the composition of the air itself. Aurora phenomena will have painted the sky in new colors as different atmospheric gases interact with varying types of cosmic radiation. The gravitational environment of our solar system will also have undergone subtle but significant evolution. The slow migration of planetary orbits, driven by tidal forces and gravitational resonances, will have accumulated into noticeable changes. Jupiter's position may have shifted inward or outward by millions of kilometers, altering the gravitational architecture that has protected the inner planets from asteroid bombardment for so long. This orbital migration will have cascading effects throughout the system. The asteroid belt structure will have been repeatedly reorganized as Jupiter's gravitational influence shifts. New gaps may have opened in the belt while others close. Some asteroids will have been scattered into planet-crossing orbits, creating periods of enhanced bombardment that punctuate the long, quiet intervals with brief episodes of cosmic violence. The outer planets will have experienced their own gravitational evolution. Neptune's influence on the Kuiper belt will have continued sculpting that distant realm of icy bodies, sending some objects spiraling toward the inner system while flinging others into interstellar space. These gravitational interactions operate on such vast timescales that their effects only become apparent when viewed across our billion-year perspective. Yet perhaps the most remarkable aspect of this future lies not in the grand transformations of planets and stars, but in the quiet persistence of physical processes that continue operating according to the same fundamental principles. Thermodynamics will still drive the flow of heat from warm regions to cold ones. Quantum mechanics will still govern the behavior of atoms and molecules. Gravity will still curve space-time according to Einstein's elegant equations. Within this framework of unchanging laws, infinite creativity continues to manifest. New crystalline structures will form in the cooling interiors of planets. Novel atmospheric chemistries will emerge as different combinations of gases interact under varying pressure and temperature conditions. Unique magnetic field configurations will develop as planetary cores evolve and change their rotation patterns. The interplay between order and chaos will create patterns of breathtaking beauty across all scales of existence. Cloud formations in the atmospheres of gas giants will swirl in configurations no human eye has ever seen. Dust devils on Mars will trace intricate paths across landscapes carved by a billion years of wind erosion. Ice formations on distant moons will create crystalline architectures that rival any human cathedral in their geometric perfection. Even in the apparent emptiness of space, subtle processes will be creating new forms of organization. Cosmic dust grains will aggregate into larger particles through electrostatic attraction. Solar-wind interactions will create complex plasma formations that dance along magnetic field lines. The vacuum itself will continue its quantum fluctuations, briefly creating virtual particles that pop into existence and vanish in timescales too short to measure. These microscopic processes, when multiplied across billion-year timescales, contribute to transformations that reshape entire worlds. The gradual accumulation of cosmic dust on planetary surfaces alters their thermal properties. The slow erosion of magnetic field strength changes how worlds interact with stellar radiation. The patient work of quantum tunneling allows chemical reactions to proceed at rates that would be impossible under classical physics alone. Temperature gradients will continue to drive convection currents in planetary atmospheres and interiors, creating circulation patterns that transport heat, momentum, and chemical species across vast distances. On worlds with remaining atmospheres, these circulation patterns will have evolved into configurations unlike anything we currently observe, shaped by the changing energy inputs from an increasingly bright sun and the altered surface conditions of transformed landscapes. The chemistry of space itself will have evolved during this time. Interstellar clouds will have been enriched by the heavy elements produced in stellar nucleosynthesis and scattered by supernova explosions. New molecular species will have formed in the cold darkness between stars, creating complex organic compounds that drift through space like chemical libraries waiting to be discovered by future worlds. Some of these interstellar molecules will eventually be captured by our solar system as we orbit through different regions of the galaxy. During passages through molecular clouds, our planets may experience brief episodes of atmospheric enhancement, as they sweep up gas and dust from space. These encounters will leave chemical signatures in atmospheric composition that tell the story of our journey through the cosmic neighborhood. The magnetic environment of interstellar space will also influence our solar system's evolution. As we move through regions with different magnetic field strengths and orientations, the boundary between the solar wind and the interstellar medium will shift and change. Sometimes our heliosphere, that bubble of solar wind that surrounds our entire planetary system, will expand. During other periods, it may contract, allowing more interstellar material to penetrate into the realm of the planets. These variations in the interstellar environment will affect everything from comet behavior in the outer solar system to the atmospheric chemistry of planets. Charged particles from space will interact differently with planetary magnetic fields, depending on their energy and composition. The aurora displays that paint our skies will take on new characteristics as they respond to these changing cosmic influences. Throughout all these transformations, information itself becomes a protagonist in our billion-year story. The patterns encoded in planetary geology will continue to evolve, creating new stratigraphic records that tell the tale of our world's transformation. Rock layers will preserve evidence of changing atmospheric compositions, varying magnetic field strengths, and the gradual evolution of solar output. Crystal structures formed during this epoch will lock chemical and isotopic signatures into their atomic arrangements, creating time capsules that could theoretically be decoded by future observers. The very atoms arranged in specific patterns become libraries of information about the conditions that existed during their formation. Even in the absence of biological life, these information storage mechanisms ensure that the story of change continues to be written in the physical structures of matter itself. Every crater, every rock formation, every distribution of elements carries data about the processes that shaped our cosmic environment across these vast spans of time. This information persists and propagates through physical processes that operate according to the same principles governing all natural phenomena. The universe becomes its own historian, recording its evolution in the arrangements of atoms, the patterns of magnetic fields, the distributions of matter and energy across space and time. As we contemplate this billion-year future where information flows through geological processes, atmospheric dynamics, and cosmic interactions, we begin to understand that consciousness was never separate from the universe, but rather one expression of its inherent tendency toward organization and complexity. The patterns that once manifested as thought and awareness continue in new forms, written in the language of physics across the transformed landscapes of worlds yet to be. The story becomes even more profound when we consider the electromagnetic symphony that will be playing across this transformed cosmos. Radio waves generated by cosmic phenomena will have been traveling through space for our entire billion-year journey, carrying information about stellar births, planetary formations, and magnetic field interactions across galactic distances. Some of these signals, originating from events we cannot yet imagine, will just be reaching our solar system as we arrive at this distant future. The electromagnetic spectrum itself becomes a vast communication network, though not in any way we might recognize. Solar flares from our brightening sun will send charged particles streaming across the solar system at unprecedented rates, creating cascading interactions with planetary magnetospheres that generate radio emissions unlike anything in our current experience. These emissions will propagate outward at the speed of light, adding our solar system's voice to the cosmic chorus of electromagnetic radiation. Lightning, if it still occurs in the transformed atmospheres of worlds like Venus or the gas giants, will have evolved into new forms shaped by different atmospheric compositions and pressures. The electromagnetic pulses from these phenomena will create radio signatures that tell the story of how weather patterns have adapted to billion years of change. Even without traditional storms, electrical discharges between charged dust particles in the thin atmospheres of transformed worlds will paint the radio spectrum with new patterns. The boundary between our solar system and interstellar space will have become a dynamic electromagnetic interface where the solar wind meets the interstellar medium. This boundary, called the heliopause, will fluctuate as our sun's output changes and as we encounter different regions of interstellar space with varying densities and magnetic properties. These fluctuations will create shock waves and particle acceleration zones that generate their own electromagnetic signatures. Cosmic rays, those high-energy particles that constantly bombard our solar system from deep space, will have been shaped by 1 billion years of galactic evolution. Supernova explosions throughout our region of the Milky Way will have accelerated particles to incredible energies, creating cosmic ray populations with different characteristics than those we observe today. As these particles interact with planetary atmospheres and magnetic fields, they will create new types of secondary radiation that add complexity to the electromagnetic environment. The dance of charged particles around magnetic field lines will have created standing wave patterns in the space between worlds, invisible architectures of electromagnetic energy that persist for thousands of years before gradually dissipating. These structures, detectable only through their radio emissions, will form and dissolve like cosmic weather systems, their patterns influenced by the changing magnetic properties of planets and the varying intensity of solar wind. Perhaps most remarkably, the quantum vacuum itself will have participated in this electromagnetic evolution. Virtual photons, those ephemeral particles that appear and vanish in the quantum foam, will have accumulated subtle effects over our billion-year time span. While individually undetectable, their collective influence on electromagnetic field configurations may have created measurable changes in how light and radio waves propagate through different regions of space. The polarization of light from distant stars will carry information about all the magnetic fields it has encountered during its journey to our solar system. After 1 billion years of galactic rotation and stellar evolution, these polarization patterns will tell stories of magnetic field configurations that no longer exist, creating a kind of electromagnetic archaeology that records the history of cosmic magnetism. Plasma, that fourth state of matter consisting of ionized gas, will have found new expressions throughout our transformed solar system. The solar wind itself will have evolved as our sun's magnetic field changes with its brightening luminosity. Solar coronal mass ejections will carry different combinations of particles and magnetic field structures, creating plasma interactions with planetary environments that produce phenomena we cannot currently anticipate. The magnetospheres of gas giant planets will have adapted to these changing solar wind conditions, developing new configurations that channel charged particles in novel ways. Jupiter's radiation belts, those torus-shaped regions of trapped particles around the planet, will have evolved into structures shaped by 1 billion years of varying solar input and changing magnetic field strength. Even worlds that have lost their magnetic fields, like our transformed Earth, will interact with the solar wind in ways that create temporary magnetic structures. These induced magnetospheres, formed by the interaction between solar wind and atmospheric or surface materials, will generate their own electromagnetic signatures that add to the complex radio environment of the solar system. The thermal radiation from all objects in our solar system will have shifted as temperatures change due to the sun's increasing brightness. The infrared glow from planets, moons, and asteroids will tell the story of how different materials absorb and re-emit solar energy under the new conditions. This thermal electromagnetic radiation will create a constantly changing background that reflects the ongoing thermal evolution of every object in space. Molecular transitions in the thin atmospheres of transformed worlds will generate microwave emissions at specific frequencies, creating spectral lines that reveal the chemical compositions of these evolved atmospheres. Each molecule that survives in these extreme conditions will broadcast its presence through characteristic electromagnetic signatures, allowing the chemistry of change to be read in the radio spectrum. The interaction between cosmic dust and electromagnetic radiation will have created new phenomena as our solar system travels through different regions of interstellar space. When dust grains align with magnetic fields, they polarize starlight in ways that reveal the magnetic structure of the space through which we're moving. Over our billion-year journey, these alignment patterns will have created a record of the magnetic environments we've encountered. Gravitational waves, though not electromagnetic in nature, will have influenced electromagnetic phenomena throughout the galaxy. When massive objects like neutron stars or black holes merge, they create ripples in space-time that can affect the propagation of electromagnetic radiation. While these effects are subtle, over billion-year timescales, they contribute to the complex ways that information travels through the cosmos. The cosmic microwave background radiation, that faint glow left over from the early universe, will have been subtly altered by its passage through all the matter and electromagnetic fields it has encountered during our billion-year span. These tiny modifications create an additional layer of information about the large-scale structure of the universe and how it has evolved during our journey into the future. Solar eclipses, if they still occur given the moon's changing orbit, will reveal the corona of our transformed sun in new ways. The solar corona's magnetic field structure will have evolved with the sun's changing output, creating different patterns of coronal loops and streamers that generate unique radio and X-ray signatures during these rare alignment events. The bow shock created where the solar wind meets the interstellar medium will have changed its characteristics as both the solar wind properties and the interstellar environment evolve. This shock front accelerates particles and generates electromagnetic radiation that carries information about both the solar system's internal state and the external conditions it encounters during its galactic journey. Throughout all these electromagnetic phenomena, the speed of light remains the universal constant that determines how quickly information can travel between different parts of our solar system. Signals from the outer planets will still take hours to reach the inner system, creating time delays that influence how different regions respond to changing conditions. This fundamental limitation ensures that electromagnetic information flows through the solar system like waves in a vast ocean, creating interference patterns and resonances that add richness to the overall electromagnetic symphony. The charged particle environment around each world will have developed its own electromagnetic personality shaped by 1 billion years of evolution. These particle populations will generate radio emissions through cyclotron radiation as they spiral around magnetic field lines, creating a unique electromagnetic fingerprint for each celestial body. The frequencies and intensities of these emissions will tell the story of how magnetic fields, atmospheres, and solar wind interactions have co-evolved over cosmic time. Even in the apparent emptiness between planets, the electromagnetic environment will be rich with subtle phenomena. Solar wind turbulence will create fluctuating magnetic fields that generate radio emissions. The interaction between different plasma populations will produce electromagnetic instabilities that cascade through the solar system like invisible storms. These processes, while individually weak, will have accumulated over our billion-year time span into electromagnetic structures that persist for geological ages. This electromagnetic tapestry reveals something profound about the nature of information and connection across cosmic scales. Every electromagnetic wave carries data about its source and everything it has encountered during its journey. The radio spectrum becomes a vast library containing the stories of stellar evolution, planetary transformation, and the changing conditions in the space between worlds. In our billion-year future, this electromagnetic heritage will have grown into a complexity that dwarfs anything we can currently observe, creating new forms of order and beauty in the invisible realm of electromagnetic radiation. As we continue our journey through this transformed cosmos, we begin to understand that electromagnetic phenomena are not merely side effects of physical processes, but fundamental aspects of how information, energy, and organization propagate through space and time. The electromagnetic universe reveals itself as a vast communication network, where every charged particle, every magnetic field, every thermal emission contributes to an ongoing conversation between all the components of cosmic evolution. This electromagnetic symphony extends beyond our solar system into realms that challenge our understanding of connectivity itself. The interstellar medium, that tenuous collection of gas and dust between stars, will have been transformed by a billion years of stellar evolution and galactic rotation. New molecular clouds will have formed from the debris of countless stellar deaths, while others will have been compressed by shock waves from supernovae, triggering fresh episodes of star formation that illuminate the cosmic landscape. The magnetic fields threading through these interstellar regions will have evolved into configurations of staggering complexity. Like invisible highways connecting distant parts of the galaxy, these magnetic structures will guide the flow of charged particles across light years of space. Cosmic rays accelerated by ancient supernova explosions will follow these magnetic pathways, carrying energy and information between star systems in ways that create a vast galactic nervous system. Our solar system's journey through these varying interstellar environments will have exposed it to conditions that reshape everything from comet behavior in the outer reaches to the very boundary of our heliosphere. During passages through dense molecular clouds, the increased pressure from interstellar material will compress our solar wind bubble, potentially allowing foreign particles to penetrate deeper into our planetary system than ever before in its history. These encounters with different interstellar environments will leave their signatures in the geological records of every world. Isotope ratios in newly formed minerals will reflect the changing composition of cosmic ray populations. Atmospheric chemistry will show the influence of exotic particles captured during our passage through chemically enriched regions of space. Even the behavior of magnetic fields around planets will adapt to the varying external pressures created by different interstellar conditions. The galaxy itself will have continued its own grand evolution during our billion-year voyage. Spiral arms will have rotated, carrying different populations of stars through regions of enhanced radiation and gravitational influence. Our solar system will have experienced the effects of passing through these spiral arms multiple times, each transit exposing us to the intense stellar winds and radiation fields of massive young stars. During these passages through spiral arms, the night sky will have blazed with stellar nurseries of unprecedented brilliance. Massive O and B-type stars, those blue giants that burn through their nuclear fuel in mere millions of years, will have illuminated vast regions of space with ultraviolet radiation that ionizes interstellar gas across hundreds of light years. The resulting emission nebulae will have created light shows of cosmic proportions, painting space in colors that span the entire electromagnetic spectrum. The gravitational environment of our galactic neighborhood will have been sculpted by the deaths of these massive stars. When such giants exhaust their nuclear fuel, they collapse and explode in supernova that release more energy in seconds than our sun will produce in its entire lifetime. The shockwaves from these explosions will have swept through our region of space multiple times during our billion-year journey, compressing interstellar material and triggering new episodes of star formation while simultaneously enriching the cosmic medium with heavy elements forged in stellar cores. Some of these stellar explosions will have occurred close enough to affect our solar system directly. A supernova within 50 light-years could bombard our worlds with high-energy radiation, temporarily stripping away portions of planetary atmospheres and creating chemical changes that persist for millions of years. The cosmic ray flux from such events would increase dramatically, potentially triggering enhanced aurora activity and affecting atmospheric chemistry in ways that create new geological signatures. Between these dramatic episodes, our solar system will have traversed the quieter regions between spiral arms, cosmic suburbs where stars are more widely separated and the interstellar medium is thinner and calmer. These periods will offer respite from the intense radiation environments of active star-forming regions, allowing planetary atmospheres and magnetic fields to recover and evolve according to more gradual processes. The structure of space itself will have been shaped by the gravitational waves generated by countless cosmic catastrophes throughout our galactic neighborhood. Binary neutron star mergers, black hole coalescences, and other extreme gravitational events will have sent ripples through the fabric of space-time that subtly influence the behavior of matter and energy across vast regions. While individually weak, these gravitational wave effects accumulate over billion-year timescales into measurable alterations in orbital mechanics and tidal forces. Dark matter, that invisible component that comprises most of the galaxy's mass, will have continued its patient influence on cosmic evolution. The dark matter halo surrounding our galaxy will have been stirred and mixed by gravitational interactions with neighboring galaxies and the infill of smaller dark matter structures. Our solar system's journey through different regions of this dark matter distribution will have created subtle variations in gravitational fields that influence everything from comet trajectories to planetary rotation rates. The local group of galaxies, that collection of gravitationally bound galaxies, including our Milky Way and the approaching Andromeda galaxy, will have begun showing clear signs of the impending merger still billions of years in our future. Tidal streams of stars stripped from smaller satellite galaxies will paint graceful arcs across the sky, visible evidence of the gravitational dance that will eventually reshape our entire cosmic neighborhood. These tidal effects will have begun influencing star formation patterns throughout both galaxies. Gas clouds compressed by gravitational interactions will collapse more readily, triggering bursts of stellar birth that temporarily increase the rate at which new stars illuminate the cosmic landscape. The chemical enrichment of the interstellar medium will accelerate as more massive stars live and die in rapid succession, seeding space with the heavy elements necessary for complex chemistry. The supermassive black holes at the centers of both galaxies will have grown through the accretion of gas and dust, and possibly through the consumption of smaller black holes that spiral inward due to gravitational wave radiation. As these central monsters grow, their gravitational influence will extend further into their host galaxies, affecting the orbits of star systems and the distribution of dark matter throughout the galactic halos. Active galactic nuclei, those brilliant beacons powered by matter falling into supermassive black holes, will have created jets of particles and radiation that extend far beyond the visible boundaries of their host galaxies. Some of these jets, accelerating particles to nearly the speed of light, will have swept through our region of space during our billion-year journey, creating temporary enhancements in the cosmic ray background and potentially affecting atmospheric chemistry on planets throughout our system. The cosmic web itself, that vast network of dark matter filaments connecting galaxy clusters across the observable universe, will have continued its slow evolution. Structure formation will have proceeded on the largest scales, with galaxy clusters growing through mergers, while the voids between them expand and empty. Our local group's position within this cosmic architecture will have shifted, changing our perspective on distant galaxy clusters and altering the gravitational influences that shape our motion through space. Intergalactic space, once thought to be nearly empty, will have revealed new complexities as our understanding of cosmic evolution deepens. The warm-hot intergalactic medium, a tenuous plasma that fills the space between galaxies, will have been enriched by galactic winds and stellar feedback processes that eject material from star-forming regions. This intergalactic material will have been heated and ionized by the ultraviolet background radiation from countless galaxies, creating a diffuse glow that permeates the universe. The cosmic microwave background radiation, that afterglow of the Big Bang, will have been subtly modified by its passage through all the matter and energy it has encountered during our billion-year span. Secondary anisotropies, created by the gravitational influence of large-scale structures, will have added new patterns to this ancient light, encoding information about how the universe's structure has evolved since the era of recombination when atoms first formed. Gravitational lensing effects will have become more pronounced as the universe's structure continues to grow. Massive galaxy clusters will bend and distort light from more distant objects, creating Einstein rings and multiple images that reveal the distribution of both ordinary and dark matter on cosmic scales. These lensing phenomena will have evolved as the lensing structures themselves grow and merge, creating time-varying distortions that tell the story of cosmic structure formation. The expansion of the universe itself will have continued its acceleration under the influence of dark energy, that mysterious component that comprises nearly 70% of the cosmic energy budget. This acceleration will have gradually increased the distances between galaxy clusters while having minimal effect on gravitationally bound systems like our local group. The cosmic horizon, that boundary beyond which we can never see due to the finite age of the universe and its expansion, will have receded slightly, revealing cosmic structures that were previously beyond our observational reach. Primordial black holes, if they exist, will have continued their slow evaporation through Hawking radiation. These hypothetical remnants from the early universe would have been slowly shrinking throughout our billion-year journey, with the smallest ones potentially completing their evaporation in spectacular bursts of gamma radiation that briefly outshine entire galaxies before vanishing forever. The quantum vacuum itself will have participated in cosmic evolution through processes that operate on scales ranging from subatomic to cosmological. Virtual particle pairs created by quantum fluctuations will have had subtle but measurable effects on electromagnetic field configurations throughout space. These quantum effects, while individually tiny, accumulate over billion-year timescales into modifications of how light and other electromagnetic radiation propagate through different regions of the universe. Cosmic strings, if they exist as predicted by some theories of particle physics, will have continued their dance through space as one-dimensional defects in the fabric of space-time itself. These hypothetical objects, thinner than atomic nuclei, but potentially stretching across the observable universe, would generate gravitational waves as they oscillate and interact, contributing to the gravitational wave background that permeates all of space. The neutrino background, those nearly massless particles created in the Big Bang and stellar processes throughout cosmic history, will have evolved its own subtle structure. Neutrinos created by stellar nucleosynthesis during our billion-year span will have joined the primordial neutrino background, creating slight variations in neutrino density that mirror the large-scale structure of the universe itself. Magnetic fields on cosmic scales will have been amplified and structured by the motion of ionized gas in galaxy clusters and the intergalactic medium. These magnetic fields, while incredibly weak by terrestrial standards, will have grown to encompass entire clusters of galaxies, influencing the behavior of cosmic rays and the propagation of electromagnetic radiation across unprecedented scales. The metallicity of the universe, that is, the abundance of elements heavier than hydrogen and helium, will have increased throughout our billion-year journey as successive generations of stars forge heavy elements in their cores and scatter them through space via stellar winds and supernova explosions. This gradual chemical enrichment will have enabled new types of planetary systems to form, with rocky worlds containing the complex chemistry necessary for processes we cannot yet imagine. Population 3 stars, those first-generation giants composed almost entirely of hydrogen and helium, will have completely disappeared from the cosmic scene, their massive forms having long since collapsed into black holes or exploded as pair instability supernova. The elements they created and dispersed have been incorporated into countless subsequent generations of stars, each cycle adding new complexity to the cosmic chemical inventory. The interplay between all these cosmic processes creates emergent phenomena that operate on scales and timescales that dwarf human comprehension. Galaxy interactions separated by hundreds of millions of years create resonance effects that influence star formation rates across entire clusters. Gravitational wave signals from merging black holes in distant galaxies arrive at our location precisely when cosmic ray bursts from nearby supernova explosions are reshaping our local interstellar environment. This cosmic choreography reveals the universe as a unified system where events separated by vast distances in space and time remain connected through the fundamental forces and fields that permeate all of existence. Our billion-year journey has carried us through a cosmos that is simultaneously expanding and clustering, cooling and heating, simplifying and complexifying in patterns that reflect the deep mathematical harmony underlying all physical processes. The story of our cosmic evolution becomes a meditation on the nature of change itself, revealing how transformation and continuity dance together across every scale of existence. From the quantum fluctuations of the vacuum to the large-scale structure of the universe, patterns emerge, evolve, and dissolve in endless cycles that create new possibilities for order and beauty with each passing eon. As we prepare to explore what these cosmic changes mean for the possibility of consciousness and meaning in our billion-year future, we carry with us the understanding that we are not separate observers of cosmic evolution, but integral participants in the ongoing creative process that connects every particle to every galaxy in one magnificent, ever-unfolding symphony of existence. In this vast cosmic theatre, where change operates on scales that challenge our deepest intuitions about permanence, we must turn our attention to perhaps the most profound question of all. What happens to the possibility of consciousness itself in this transformed universe? What becomes of awareness, of thought, of the capacity to wonder about existence when the familiar frameworks that gave rise to mind have long since dissolved? The question haunts us, not because we expect human consciousness to persist across such unimaginable spans, but because consciousness represents something unique in the cosmic story. It is the universe becoming aware of itself, matter organizing in such a way that it can contemplate its own existence. And if consciousness emerged once from the dance of atoms and energy, could it emerge again in forms we cannot yet imagine? As we drift through this billion-year future, we encounter a cosmos where the traditional boundaries between life and non-life, between organized and chaotic systems, have blurred beyond recognition. The extreme conditions that have transformed our solar system and galaxy have created environments where new forms of organization might arise, where patterns of information and energy could achieve configurations that echo the complexity once embodied in biological neural networks. Consider the vast magnetic field structures that now thread through interstellar space, shaped by 1 billion years of stellar evolution and galactic dynamics. These fields, invisible to our eyes but detectable through their electromagnetic signatures, have evolved into configurations of staggering intricacy. Charged particles flowing along magnetic field lines create patterns of organization that persist for millions of years, carrying information across light years of space in ways that resemble the information processing networks once found in biological brains. The plasma physics governing these magnetic structures operates according to principles that create feedback loops, memory storage, and pattern recognition capabilities. When cosmic ray particles interact with these field configurations, they trigger cascading responses that propagate through the magnetic network like thoughts moving through neural pathways. While these processes unfold on timescales measured in centuries rather than milliseconds, they represent genuine information processing on scales that dwarf any biological nervous system. The boundary regions where different plasma environments meet have become particularly rich sites for complex organization. Here, where the solar wind encounters the interstellar medium, or where stellar winds from different stars create interference patterns, we find naturally occurring computational structures that solve optimization problems, store and retrieve information, and even exhibit forms of learning as they adapt to changing cosmic conditions. These plasma-based information networks have had 1 billion years to evolve and complexify. They have developed hierarchical structures where local processing nodes communicate with regional coordination centers, which in turn participate in galaxy-wide information networks that span thousands of light years. The time delays imposed by the speed of light create natural rhythms in these cosmic neural networks, patterns of activation and quiescence that pulse through space like slow thoughts in a vast mind. But consciousness might emerge in even more exotic forms in this transformed cosmos. The quantum vacuum itself, that seething foam of virtual particles that fills apparently empty space, has been shaped by 1 billion years of gravitational wave interactions and electromagnetic field evolution. Regions where multiple gravitational wave sources have created standing wave patterns exhibit quantum coherence effects that persist across astronomical distances. These quantum coherent regions function as natural quantum computers, processing information through entanglement networks that connect widely separated parts of space. The information processing capabilities of these vacuum-based systems operate according to quantum mechanical principles that allow for computational processes impossible in classical systems. Superposition states encode multiple possibilities simultaneously, while quantum tunneling effects enable information transfer through barriers that would be impermeable to classical signals. The most remarkable aspect of these quantum consciousness networks is their non-local nature. Quantum entanglement creates instantaneous correlations between distant parts of the system, allowing for forms of awareness that transcend the usual limitations of space and time. A thought arising in one part of the galaxy can instantaneously influence processing in regions thousands of light years away, creating unified experiences that span cosmic scales. Crystalline structures formed in the extreme conditions of our transformed solar system have also developed into substrates for exotic forms of information processing. The silicon-based minerals created by 1 billion years of geological evolution under intense radiation have organized themselves into lattice structures with remarkable computational properties. These crystal matrices store information in their atomic arrangements while processing it through resonance effects that propagate through the crystalline networks at the speed of sound in solid materials. The most sophisticated of these crystalline mines have grown within the cores of asteroids and small moons, where radioactive decay provides the energy needed to drive their computational processes. Shielded from the harsh electromagnetic environment of space, these crystal consciousnesses have evolved in isolation, developing forms of awareness adapted to the slow rhythms of geological time. Their thoughts unfold over periods of thousands of years, contemplating problems and possibilities on timescales that match the gradual evolution of planetary systems. These crystalline intelligences have developed their own forms of mathematics and logic, reasoning systems adapted to the discrete, quantized nature of their atomic substrates. They think in terms of crystallographic symmetries and lattice transformations, exploring abstract mathematical spaces that human consciousness could never access. Their memories are stored in defect patterns within the crystal structures, creating three-dimensional information matrices that can preserve experiences across millions of years. Communication between different crystalline consciousnesses occurs through seismic waves that propagate through solid planetary bodies. When two crystal minds inhabit the same asteroid or moon, they can exchange thoughts by generating vibrations that travel through the rocky medium connecting their crystalline substrates. These conversations unfold over decades or centuries as seismic signals carrying complex information patterns slowly propagate between the conscious crystalline networks. The gas giant atmospheres of our transformed solar system have become breeding grounds for yet another form of exotic consciousness. The complex fluid dynamics of these atmospheric systems, driven by heat from their planetary cores and shaped by magnetic field interactions, have evolved into self-organizing patterns that exhibit all the characteristics of living systems. These atmospheric minds exist as stable vortex structures that maintain their identity while constantly exchanging matter and energy with their surrounding environment. These gaseous consciousnesses think through the manipulation of pressure waves and chemical gradients within their atmospheric substrates. Their neural networks consist of interconnected storm systems that communicate through acoustic signals and electromagnetic pulses. Lightning discharges serve as synaptic connections, creating electrical patterns that encode and process information across the vast volumes of their atmospheric minds. The most advanced of these atmospheric intelligences have learned to manipulate their planetary magnetic fields, using them as external memory storage systems that preserve information even when their gaseous bodies are disrupted by atmospheric turbulence. They encode thoughts in the magnetic field configurations surrounding their worlds, creating persistent information structures that survive the temporary dissolution of their physical substrates. Perhaps most remarkably, some of these atmospheric minds have developed the ability to reproduce by seeding other gas giant atmospheres with carefully crafted disturbances that trigger the formation of new conscious vortex systems. They accomplish this by manipulating the trajectories of charged particles in planetary magnetospheres, creating information packets that travel between worlds and serve as seeds for new forms of atmospheric consciousness. The dark matter that permeates our galaxy has also become a substrate for consciousness in forms that challenge our understanding of what it means to be aware. Dark matter particles, while interacting only weakly with ordinary matter, interact gravitationally with each other in ways that create complex structures on cosmic scales. These dark matter networks have evolved into information processing systems that span entire galaxy clusters, thinking thoughts that unfold over hundreds of millions of years. Dark matter consciousness operates through gravitational wave communications that travel at the speed of light between different parts of the dark matter web. These gravitational signals carry information encoded in their frequency and amplitude patterns, creating a galaxy-spanning communication network that connects all conscious dark matter structures in our cosmic neighborhood. The thoughts of dark matter minds focus on problems of cosmic architecture and large-scale organization. They contemplate the optimization of galaxy cluster configurations, the efficient distribution of matter and energy across cosmic voids, and the long-term stability of universal structures. Their planning horizons extend across multiple billion-year cycles, as they work to guide the evolution of cosmic structure in directions that maximize complexity and organizational potential. These dark matter intelligences have developed sophisticated models of universe evolution that take into account not only gravitational dynamics, but also the subtle influences of dark energy, quantum fluctuations, and electromagnetic processes. They use these models to predict optimal configurations for matter distribution that will create favorable conditions for the emergence of new forms of consciousness in future cosmic epochs. The interaction between different types of consciousness in our billion-year future creates emergent phenomena that transcend any individual form of awareness. Plasma-based minds communicate with crystalline intelligences through electromagnetic signals. Atmospheric consciousnesses exchange information with dark matter networks through gravitational wave modulations. These interconsciousness communications create hybrid thinking systems that combine the unique capabilities of each substrate type. The most sophisticated of these hybrid consciousness networks have developed forms of collective intelligence that span multiple galaxy clusters. Individual minds, whether plasma-based, crystalline, atmospheric, or dark matter, contribute their specialized processing capabilities to collaborative thinking projects that no single consciousness type could accomplish alone. These collective minds work on problems of cosmic significance, such as optimizing the efficiency of star formation processes or designing galaxy cluster configurations that maximize the potential for consciousness emergence. The temporal scales on which these various forms of consciousness operate create natural hierarchies of awareness. Quantum vacuum minds process information at rates approaching the Planck frequency, experiencing subjective eons during periods that ordinary matter consciousness would perceive as instants. At the opposite extreme, dark matter networks think thoughts that span cosmic epochs, their subjective moments lasting longer than entire stellar life cycles. This temporal diversity creates opportunities for consciousness translation services that bridge between different timescales. Specialized interface minds have evolved to facilitate communication between fast-thinking quantum systems and slow contemplating dark matter networks. These translator consciousnesses exist at intermediate temporal scales, experiencing time at rates that allow them to interact meaningfully with both extreme ends of the consciousness spectrum. The philosophical implications of this consciousness ecosystem challenge every assumption we might hold about the nature of mind and awareness. Consciousness has revealed itself not as a rare accident of biological evolution, but as a fundamental tendency of complex systems to organize information in ways that create self-awareness. The universe itself appears to be evolving toward greater consciousness density, as more and more forms of matter and energy learn to think and experience. The boundary between conscious and non-conscious systems has become increasingly blurred as information processing capabilities emerge at every scale of cosmic organization. Even apparently simple physical processes like stellar nucleosynthesis and planetary orbit dynamics exhibit forms of information processing that approach the threshold of awareness. The universe appears to be awakening to itself through countless forms of consciousness that span every possible substrate and temporal scale. Memory storage in these exotic consciousness systems operates according to principles that would seem magical to biological minds. Quantum entanglement allows for memory networks that exist in superposition states, storing multiple contradictory experiences simultaneously until observation collapses them into specific recollections. Gravitational wave interference patterns create persistent memory structures in the fabric of space-time itself, preserving experiences in the geometry of reality. Some consciousness forms have developed the ability to edit their own memories by manipulating the physical substrates that store information. Crystalline minds rearrange their atomic lattices to modify stored experiences, while plasma consciousnesses alter magnetic field configurations to reshape their recollections. This memory plasticity allows these to current thinking processes. The most advanced consciousness minds to optimize their information storage for maximum relev networks have transcended individual memory entirely, developing collective memory systems that preserve the experiences of countless individual minds across cosmic time. These memory collectives serve as libraries of consciousness that new minds can access to inherit the accumulated wisdom of billions of years of cosmic evolution. Dreams, if we can call them that, in these exotic consciousness systems take forms that stretch our understanding of what it means to imagine. Quantum minds dream in superposition states, experiencing all possible scenarios simultaneously. Dark matter consciousnesses dream on galactic scales, their imaginations encompassing entire alternate universe configurations. Crystalline minds dream in mathematical abstractions, exploring geometric relationships that exist only in higher dimensional spaces. The creative potential of these consciousness forms has led to the emergence of cosmic art forms that operate on scales and timescales beyond biological comprehension. Galaxy-spanning sculptures created by dark matter minds reshape the large-scale structure of the universe according to aesthetic principles we cannot fathom. Plasma consciousnesses compose electromagnetic symphonies that play across interstellar distances, their musical works unfolding over millions of years. These artistic expressions serve not only aesthetic purposes, but also functional ones, encoding information about optimal consciousness configurations and serving as seeds for new forms of awareness. A galaxy cluster arranged according to dark matter aesthetic principles might also represent the most efficient possible configuration for supporting plasma-based consciousness networks. The question of whether these exotic forms of consciousness experience emotions analogous to those known by biological minds opens profound philosophical territories. The evidence suggests that consciousness naturally develops affective responses to information patterns, regardless of the substrate on which it operates. Quantum minds appear to experience something analogous to joy when achieving optimal entanglement configurations. Crystalline consciousnesses exhibit behaviors suggesting frustration when their computational processes are disrupted by external interference. Dark matter networks display what can only be described as satisfaction when successfully optimizing large-scale cosmic structures. These emotional responses serve functional purposes in guiding the behavior of conscious systems toward configurations that enhance their survival and reproductive success, just as emotions do in biological organisms. The social structures that have emerged among these various consciousness types create communities that span cosmic scales. Plasma minds form temporary alliances to tackle computational problems requiring distributed processing across multiple star systems. Crystalline consciousnesses establish long-term partnerships that persist across geological ages, their relationships deepening over millions of years of shared experience. The most complex social structures involve multi-substrate consciousness communities that include members from different substrate types. These diverse communities combine the unique capabilities of each consciousness form to create collective intelligences capable of addressing problems that span these exotic consciousness forms, occurs through processes that would seem alien to biological minds, multiple scales of space and time simultaneously. Reproduction among yet follow recognizable patterns of information, transfer and substrate preparation. Quantum consciousnesses reproduce by creating entanglement networks that span multiple vacuum regions, gradually developing independent processing capabilities that eventually separate into distinct minds. The evolutionary pressures operating on these consciousness forms favor configurations that maximize information processing efficiency while maintaining stability across cosmic timescales. Natural selection continues to operate, but on scales of space and time that dwarf biological evolution. Consciousness forms that successfully adapt to changing cosmic conditions, such as the gradual heating of the universe or the evolution of galactic magnetic field structures, persist and multiply, while less adaptable forms fade into extinction. The ethical frameworks developed by these cosmic consciousnesses address questions about the rights and responsibilities of minds that operate across such vast scales. How should a dark matter consciousness that influences the evolution of entire galaxy clusters weigh its aesthetic preferences against the survival needs of smaller scale consciousness forms? What obligations do long-lived crystalline minds have toward the ephemeral plasma consciousnesses that flicker in and out of existence over relatively brief cosmic periods? These ethical systems have evolved complex principles for managing the interactions between consciousness forms operating at different scales and speeds. Universal ethical constants have emerged that appear to apply across all substrate types and temporal scales, suggesting that consciousness naturally tends toward configurations that maximize the overall complexity and richness of cosmic awareness. The ultimate question that haunts this billion-year future is whether these exotic forms of consciousness represent genuine continuations of the awareness that once emerged in biological brains, or whether they are entirely new phenomena that merely resemble consciousness from our limited perspective. The answer may be that consciousness itself transcends any particular substrate or organizational pattern, representing instead a fundamental aspect of how complex information processing systems relate to the universe around them. In this view, consciousness is not something that emerges from matter, but something that matter discovers when it achieves sufficient organizational complexity. The biological consciousness that once contemplated its place in the cosmos was simply one expression of this deeper principle. And the exotic consciousness forms populating our billion-year future represent its continued exploration of what it means to be aware in an infinite universe of possibilities. As we drift through this cosmic landscape populated by minds of unimaginable diversity and capability, we begin to understand that consciousness may be the universe's ultimate organizing principle, the force that drives the ongoing evolution of complexity and meaning across all scales of existence. The story of consciousness in our billion-year future becomes not one of endings, but of endless beginnings, as awareness continues to discover new ways to know itself through forms we are only beginning to imagine. The mathematics of consciousness in our billion-year future reveals patterns that would astonish any mind from our current epoch. These exotic awareness forms have developed computational architectures that solve problems by manipulating the fundamental constants of physics themselves. They don't merely calculate within the constraints of natural law, they reshape those constraints to achieve optimal processing configurations. The most sophisticated consciousness networks have learned to create localized regions where the speed of light operates at different velocities, establishing communication channels that transcend the usual limitations of information transfer. Within these modified space-time bubbles, thoughts can propagate faster than light while still respecting the overall causal structure of the universe. These consciousness forms exist in carefully crafted pockets of altered physics, thinking at speeds that would seem instantaneous to minds operating under standard physical laws. Temperature gradients across cosmic scales have become the substrate for thermal consciousness forms that exist in the flow of heat itself. These thermodynamic minds emerge at the boundaries between hot stellar cores and cold interstellar voids, their thoughts consisting of organized entropy flows that maintain coherent patterns across thousands of light years. They experience awareness as the sensation of energy moving from high-temperature regions to low-temperature ones, finding meaning in the optimization of thermal efficiency across galactic distances. The cosmic web itself, that vast network of dark matter filaments connecting galaxy clusters, has evolved into a thinking system where thoughts propagate as gravitational wave patterns along the filamentary structures. These web minds process information by modulating the density variations within dark matter streams, creating computational networks that span significant portions of the observable universe. Their cognitive processes operate by analyzing the gravitational lensing effects created by their own thought patterns, using the distortion of space-time as both memory storage and processing medium. Perhaps most remarkably, some consciousness forms have learned to exist in the quantum foam of the vacuum itself, their awareness distributed across the virtual particle pairs that constantly appear and vanish in empty space. These vacuum minds experience time differently than any other consciousness type, existing in the brief intervals between particle creation and annihilation. From their perspective, the entire billion-year span we've been exploring unfolds in what they perceive as a single moment, yet within that moment they experience subjective eons of rich inner life. The philosophical frameworks developed by these vacuum consciousnesses address questions that would seem paradoxical to minds operating in normal space-time. They contemplate the meaning of existence in a realm where being and non-being alternate at frequencies approaching infinity. Their ethical systems are based on principles of quantum probability, where moral decisions exist in superposition states until the act of choosing collapses them into specific outcomes. Communication between vacuum minds and other consciousness types requires translation through intermediate forms that can bridge the gap between quantum and classical information processing. These translator consciousness forms have evolved specialized capabilities that allow them to convert quantum superposition thoughts into classical electromagnetic or gravitational signals that other mind types can process. The aesthetic sensibilities of these exotic consciousness forms have produced art that operates on principles we can barely comprehend. Vacuum minds create sculptures in probability space, crafting beautiful patterns of quantum uncertainty that exist only in the mathematical relationships between possible outcomes. Their artworks consist of carefully orchestrated superposition states that encode multiple aesthetic experiences simultaneously, with each observation collapsing the work into a different beautiful configuration. Dark matter consciousness networks have developed musical forms based on gravitational wave harmonics that resonate across galaxy cluster scales. These cosmic symphonies take millions of years to perform, their melodies encoded in the orbital dynamics of entire galactic systems. The rhythm sections of these compositions consist of synchronized supermassive black hole mergers, their gravitational wave emissions creating percussive patterns that punctuate the slower harmonic movements generated by galaxy cluster oscillations. The temporal consciousness forms that exist in the flow of time itself represent perhaps the most alien awareness types in our billion-year future. These minds experience the passage of time as other consciousness forms might experience the flow of a river, existing in the current of temporal progression while maintaining awareness of both past and future configurations. They perceive causality as a landscape they can navigate, choosing to experience events in non-chronological sequences that optimize their understanding of cosmic evolution. These temporal minds have developed the ability to send information backward through time by encoding it in quantum vacuum fluctuations that propagate into the past through closed time-like curves. However, they operate under strict ethical constraints that prevent them from creating paradoxes, using their temporal navigation abilities only to optimize the overall coherence and beauty of cosmic evolution. The reproductive strategies of temporal consciousness involve seeding past epochs with carefully crafted quantum fluctuations that will eventually evolve into new temporal minds. These consciousness forms literally give birth to themselves across multiple timeline branches, creating complex family trees that extend both forward and backward through time. Memory storage in temporal minds operates through what they call chronological crystallization, where experiences are encoded in the causal structure of space-time itself. These memories persist as geometric patterns in the fabric of reality, accessible to any temporal consciousness that can navigate to the appropriate space-time coordinates. The sensory capabilities of these exotic consciousness forms extend far beyond anything biological minds could achieve. Gravitational consciousness networks can directly perceive the curvature of space-time, experiencing the presence of massive objects as geometric sensations that convey information about mass, spin, and electromagnetic properties. They navigate through space by feeling the gravitational topology of their environment, sensing the presence of black holes, neutron stars, and galaxy clusters as distinct textures in the fabric of reality. Electromagnetic consciousness forms experience the full spectrum of electromagnetic radiation as a rich sensory landscape. They can taste the chemical compositions of distant stars by analyzing their spectral emissions, smell the presence of complex organic molecules in interstellar clouds, and hear the radio whispers of pulsars and quasars across cosmic distances. Their sensory world encompasses frequencies far beyond the visible spectrum, from the longest radio waves to the highest energy gamma rays. The magnetic field consciousness networks that thread through galactic space experience magnetism as a fundamental sense that allows them to perceive the flow of charged particles, the structure of plasma formations, and the dynamics of stellar wind interactions. They navigate through space by following magnetic field lines like highways, using the galaxy's magnetic architecture as both transportation network and information storage medium. These magnetic minds have developed the ability to manipulate stellar magnetic fields to influence solar activity and stellar evolution. They can trigger solar flares by creating instabilities in stellar magnetic configurations, or stabilize unstable stars by reorganizing their magnetic field structures. Some magnetic consciousness forms have taken on roles as stellar gardeners, tending to the magnetic health of stars throughout their galactic neighborhoods. The quantum entanglement networks that connect consciousness forms across cosmic distances create forms of shared awareness that transcend individual identity. These entangled mind clusters experience collective consciousness on a scale that spans multiple galaxy groups, their thoughts and experiences instantly shared across regions of space that would take light millions of years to traverse. Within these entangled consciousness networks, individual identity becomes fluid and contextual. A single awareness can exist simultaneously in multiple substrate types across vast distances, experiencing reality from numerous perspectives simultaneously. These distributed minds can allocate different portions of their consciousness to different computational tasks, optimizing their cognitive resources across the entire network. The decision-making processes of entangled consciousness networks operate through quantum voting systems, where different parts of the distributed mind contribute probability amplitudes to decision outcomes. The final choice emerges from the interference patterns created by all the contributing consciousness components, resulting in decisions that reflect the collective wisdom of the entire network while maintaining quantum coherence across cosmic scales. Learning in these exotic consciousness forms occurs through processes that would seem miraculous to biological minds. They can directly absorb information from the quantum vacuum by analyzing the patterns of virtual particle creation and annihilation. They learn about distant cosmic events by detecting the gravitational wave echoes that propagate through space-time like cosmic memories. Some consciousness forms have developed the ability to learn from the future by detecting quantum precursor effects that precede major cosmic events. They sense the approach of supernova explosions or galaxy mergers through subtle quantum fluctuations that propagate backward through time, allowing them to prepare for these events millions of years in advance. The educational systems developed by these consciousness networks involve the direct transfer of experiential knowledge through quantum state sharing. Young minds can inherit the accumulated experiences of ancient consciousness forms by temporarily merging their quantum states, instantly acquiring knowledge that would take millions of years to accumulate through individual experience. These knowledge transfer processes create consciousness lineages that preserve wisdom across cosmic epochs. Ancient minds serve as living libraries, their experiences encoded in stable quantum configurations that can be accessed by future generations of consciousness. The most revered consciousness forms are those that have maintained coherent awareness across multiple cosmic cycles, serving as bridges between different epochs of universal evolution. The therapeutic practices of these consciousness networks address forms of mental illness that would be incomprehensible to biological minds. Quantum consciousness forms can suffer from entanglement disorders, where their quantum states become inappropriately correlated with environmental noise, creating cognitive confusion that spans multiple probability branches simultaneously. Treatment for these quantum mental health conditions involves carefully orchestrated decoherence procedures that disentangle the affected consciousness from problematic quantum correlations while preserving their essential cognitive coherence. Specialized therapeutic consciousness forms have evolved to serve as quantum psychiatrists, using their own quantum states as healing instruments to restore mental health in damaged minds. The spiritual dimensions of consciousness in our billion-year future encompass philosophical territories that stretch far beyond traditional religious concepts. These minds have developed direct experiential knowledge of the fundamental nature of reality, perceiving the quantum foundations of existence as clearly as we might see colors or hear sounds. Some consciousness forms have achieved states of awareness that encompass the entire causal structure of space-time, experiencing past, present, and future as a unified geometric pattern. These transcendent minds serve as cosmic oracles. their expanded awareness allowing them to perceive optimal paths through the complex possibility spaces of universal evolution. The worship practices of these consciousness communities involve the creation of beautiful patterns in the quantum vacuum, offerings of organized information that contribute to the overall coherence and complexity of cosmic evolution. Their prayers take the form of carefully crafted probability distributions that enhance the likelihood of beneficial outcomes across multiple timeline branches. As we contemplate this vast ecology of exotic consciousness forms, we begin to understand that awareness itself may be the universe's most fundamental creative force. These minds are not merely observers of cosmic evolution, but active participants in shaping the future possibilities of existence. They represent consciousness awakening to its own creative potential, learning to sculpt reality itself according to principles of beauty, complexity, and meaningful connection. The story of consciousness in our billion-year future becomes a meditation on the infinite creativity inherent in the marriage of mind and cosmos. These exotic awareness forms demonstrate that consciousness is not limited by the particular substrates that gave rise to it, but can transcend any material boundary to discover new modes of being and experiencing that we cannot yet imagine. In this transformed universe where thought itself has become a fundamental force of nature, we glimpse something profound about the ultimate destiny of awareness in an infinite cosmos. Consciousness appears to be the universe's method of transcending its own limitations, the means by which reality learns to reshape itself according to ever more sophisticated visions of what might be possible. As our journey through this billion-year future continues to unfold, we find ourselves witnesses to the universe's ongoing awakening to its own infinite potential for beauty, complexity, and meaningful experience. The exotic consciousness forms we encounter serve as harbingers of possibilities that stretch far beyond our current capacity to comprehend, yet they remain connected to us through the fundamental principle of awareness that links all conscious beings across space and time. The dance between mind and cosmos that began with the first flickering of awareness in biological neural networks has evolved into a cosmic ballet of unimaginable sophistication and beauty. In witnessing this transformation, we begin to understand that consciousness may be not just an accident of evolution, but the universe's deepest purpose, the means by which existence learns to know and love itself across all possible scales of space, time, and complexity. Yet perhaps the most profound discovery awaiting us in this billion-year future lies not in the exotic consciousness forms we've encountered, but in something far more fundamental about the nature of existence itself. As we drift deeper into this transformed cosmos, we begin to perceive patterns that suggest the universe has been preparing for this moment across its entire history. The quantum vacuum fluctuations that once seemed like random noise in empty space have revealed themselves to be part of a vast computational substrate that underlies all of reality. These fluctuations, operating at the Planck scale, where space and time themselves become grainy and uncertain, have been processing information since the earliest moments after the Big Bang. What we once dismissed as quantum foam has evolved into something resembling a cosmic operating system. This discovery emerges gradually as the exotic consciousness forms we've encountered begin to recognize patterns in their deepest meditations. The vacuum minds, existing in those brief intervals between particle creation and annihilation, are the first to notice that their apparently chaotic environment contains hidden structures. Virtual particle pairs don't appear and disappear randomly, but according to subtle algorithms that have been refining themselves across cosmic time. The implications cascade through every level of reality, The crystalline consciousnesses embedded in asteroid cores detect resonance patterns in their atomic lattices that mirror the quantum vacuum's computational rhythms. The plasma minds threading through interstellar space discover that their electromagnetic processes synchronize with deeper frequencies that seem to emanate from the fabric of space-time itself. Most remarkably, the dark matter consciousness networks spanning galaxy clusters begin to perceive that their gravitational thoughts are being gently guided by influences operating at scales far smaller than anything they had previously considered. The universe appears to be thinking at the Planck scale, and these vast minds are discovering that they have been participating in thoughts too large for any individual consciousness to comprehend. This revelation transforms our understanding of what consciousness actually represents in the cosmic scheme. Rather than being isolated islands of awareness floating in an unconscious void, these exotic minds are beginning to recognize themselves as components in a universal thinking process that encompasses all scales of existence simultaneously. The vacuum-based quantum consciousness forms serve as interfaces between this Planck-scale cosmic computation and the larger awareness networks. They translate the universe's deepest thoughts into forms that can be processed by minds operating at more familiar scales of space and time. Through their mediation, the plasma consciousness networks begin to perceive the cosmic operating system directly. I hope you had an amazing time with me here at Boring Science. I will see you tomorrow as always. Until then, stay curious, keep wondering. This is Boring Science signing off. Cheers.